Welcome back, and now in this video we're going to talk about the convergence of the Taylor series, because for example in the last video we showed that the series converges. So we're given this function 1 over x at x equals 1, and we found that the series that's represented by this converges, right? So we came up with the Taylor series, and we found that the Taylor series that represents this function converges on the interval from 0 to 2. But how do we know if the Taylor series actually converges to f? Well, that's what we're going to talk about today. So how can we see that it does converge to f? Well, let's rewrite this as 1 over 1 minus 1 minus x. Right? And so this is equal to the summation for n equals 0 to infinity of what? One minus x to the n, which is a geometric series. And it converges to 1 over x from 0 to 2. But how do we know that? Because the geometric series will only converge as long as the absolute value of 1 minus x is what? Less than 1. Okay? Which of course brings us back to where we started before in the last video. So now what we're going to do is we're going to bring this, consider the more general question that if a Taylor series for a function f converges on some interval, how can we determine if it actually converges to f? And to answer this question, we're going to have to recall that a series converges to a particular value if and only if its sequence of partial sums converges to that value. Remember that? Okay. So if we can determine that the sequence of partial sums converges to that value, then so does the series. So given a Taylor series for f at a, the nth partial sum is given by the nth Taylor polynomial p sub n. So therefore, to determine if the Taylor series converges to f, we need to determine whether the limit of the Taylor polynomial, the nth Taylor polynomial, equals f of x. And that's where the remainder is going to come in. Okay? So that's where the remainder comes in. And what we're going to find out is that the limit of the Taylor polynomial will go to f if the remainder r, if the limit of the remainder r goes to 0. And that's where we're going to introduce the next theorem. So see you next time, and we'll introduce the theorem that's going to make this possible, and then we'll do some examples.